Hello everyone, can you hear me? Um, Welcome to the Emerging Bioacoustician Days. Welcome to the Journée des Jeunes Bioacousticiens. Congratulations for being here. I know that for many of you it has been quite a difficult trip yesterday or today. This is the third edition, not the second, but that's fine. Before we start, a quick weather warning. I haven't checked the weather forecast, but for Wednesday it will be very warm. Today it will be warm, so just keep the shutters closed in the rooms. Open the windows when it's cool in the morning and in the evening, and drink a lot of water if you don't want to dehydrate. The room will probably warm up quite fast in the afternoon, so just be safe. And if you see a dangerous situation, whether you need a fire brigade, an emergency paramedic team, or police, called 112, and you will have some people responsible on the line. They will send you the right people. This is so don't worry too much. It's not so terrible. We had way worse temperature before in France, but it's just be mindful, be careful, and everything will be fine. There is no reason to panic, but just for you to be aware of. This conference is very cheap, as you all know, but money has to come from somewhere, and it's necessary to thanks all of our sponsors that are giving us money. Especially Artesis, that has given us a lot of money, the Fondation Lamer and the Company of Biologists as well. We won't, and now we are the organizing team. You can see us around. If you need some help, you can come to us. We have orange outline on our badges, so if you have a problem, come to us. April unfortunately cannot be here today, but she has been of great help, and I think we should remember her. She's not dead, she's just in Canada. she couldn't come, so it's just such she cannot be here, but yeah, and the others, you can see us all around for the rest of the conference. The Emerging Bioacoustician Days, it's the third edition, as I said. The first edition was in 2023, and they were only starting. There wasn't as many people as today. We are not doing as great as last year, but I think it's fine. And next edition, we will need some people to help us. There are already people that have mentioned that they would be interested. So if there is more people that are considering this option, feel free to come talk to us, and we can explain you what you will have to do, and that the situation is not so bad for organizing a conference, and it can be a great opportunity. For many of you already know this, but there is only 2 keys per room, so you have to share them with your roommates, and you need the keys to open the door of your bedrooms, but also the door at the entrance and the gate. So don't forget your keys, it's very important, and you will need them if you want to go outside at night. The door and the gate automatically closed at 8:30 in the evening, and opens up at 8:30 in the morning. Lunch will be at 8 a.m. for the breakfast, 12 for lunch, and 7 for dinner. Don't be late, it will be annoying for the people organizing the lunch. And yes, you have to be a bit quieter past 10 p.m. On the last day, bring your pillows and every bedsheets in the basket just near the staircases. And if you want to talk when it's supposed to be quiet after 10 p.m., you can you can talk in the entrance. in the small part of the cafeteria that is opening on the street, and in the restroom that is just near the cafeteria, there is a sofa, there is couches, so it's very comfortable, and you can close the door and it won't annoy people. Also, mind the fact that on this part of the building there is rooms that will be occupied by other people from that are not part of the conference, so avoid talking too much after 10 p.m. in the cafeteria. So now if we look quickly at the schedule, so today we will have sessions of ecoacoustic, sounding time, plenary from GP Rasmussen from Denmark is in the room. You may have recognized his dog. Please don't feed him. You can pet it, but don't feed him. It's just for your information. We will also have our sponsors that will give a few words, the SWECA and the Fondation de la Mer, and we will conclude the day with the poster sessions from people with posters. They will give a quick presentation of their posters, and then you are free to go talk to them. Tomorrow, session Smart Listening, Developing Bioacoustic Tools, Perception and Production of Sound, a plenary by Michel Spearings. I'm not sure if I'm pronouncing it well. Lorena, you will correct me. And you will have also the workshop. Depending on what you choose, it will be Applied Bioacoustic or AI. And we will conclude the day by the general meeting, where we will designate the next organizing committee, and you can have a review of how we use the money we received. Finally, on Wednesday afternoon, if the temperature and the storms are not so terrible, you may wish to have a walk in the city. There is a nice church, a few skeletic buildings, and the river Seine. I've been told that it's a really nice place to have a walk, but do this if the temperature are not too hot and if there is no storm. And on Thursday will be the last session, acoustic monitoring and first note, novel characterization and repertoire, and we will have a plenary by Corentin Troussard before thanking you for your presence and saying goodbye. We will have lucky draw. The balls are here. You can write your name and fold it to be drawn it. We have per a free publication worth approximately 3,000 euros. So that's the best prize. And the first prize, we also have recorders for bats from Apodemus, and I don't remember if it's only for bats or if it's universal from Frontier Labs. And we also have a few water bottles from Wildcare that we are using in the organizing team. So this can be also won in this lucky draw. Before I finish, I would like to thank you all for being here today, of course, and also remind you a few things. If you are worried, remember that there may be 60 people in the room right now, but maybe only 10 will remember about your presentation or being really interested. So don't worry too much about it, and remember that in 10 years, people won't remember at all. So relax, we're not here for that. And as I said, my former supervisor, when I asked him advices for a presentation for conference last year, he told me, have fun, make friends, no enemies, and don't say anything you're not 100% sure. So on this last one, we're the Emerging Bioacoustician Day, so we will tolerate 90% confidence, 95% confidence. Thank you all.
Some of you still haven't sent the image rights and declaration form, so please remember to send it to us. Okay? Thank you.
And also now we are going to start the presentations and just to explain.
Thank you. Do you have a clicker? Hi everyone. Can you hear me okay? Yeah. Okay, I'm very happy to be the first talk so I can relax for the whole rest of the conference. My name's Amber and I am a PhD student working at the University of St Andrews, based in Scotland. And today I'm going to present some findings from one of my chapters, which is using passive acoustic monitoring and AI to explore responses of forest birds to human recreation in Scotland. So I'll start off by giving you a bit of landscape context. This is the landscape that I'm predominantly working in. It's in the Cairngorms National Park in Scotland, just above Edinburgh there, kind of at the base of the Scottish Highlands. And this is the largest ecological restoration project in the UK. So it's home to many sensitive species, but it's also a tourism hotspot. So it attracts nearly 2 million visitors every single year. And in Scotland, in 2003, we had what we call the Land Reform Act, which gives a right to roam. So it means that people are able to access any part of the landscape that they want to in Scotland, under some caveats that they have to have dogs under close control. But that means that if you're an animal living in the forest, it's very likely that you're going to be coming into contact with people. And that can have varying effects. So there's some global reviews that suggest predominantly the effect of people in these landscapes can be negative. So you could have elevated stress if you're a species living in these environments. You can increase your energy expenditure. People could disrupt mating or disrupt feeding. And these patterns can actually trickle up to changing where animals choose to live. So it actually changes the habitats that they choose to select. And there's a general consensus that this can contribute to general patterns of lowered biodiversity. But on the flip side, humans can also provide some resources for certain species, and certain species are much more tolerant. They can also provide what we call a human shield effect, where predators can be discouraged from being active in areas where there's high human presence, which means that as a prey species, you might quite like to be residing in these areas for a bit more safety. So the species that I'm going to focus on today are woodland songbirds. So this was an acoustic study, so I decided to stick with the species that are known to be very vocal. But I did just want to point out my favourite species in the bottom left there. That's the western capercaillie. I think you have them in France as well. But this is a critically endangered species in Scotland. It's a ground nesting species, and anyone that's doing work on them, please come and talk to me, because I'm monitoring those with camera traps, so I'm not using bioacoustics, but I do, I'm really interested in them. So the question that I was interested in asking was, how does structural and functional recreation affect call rates of these woodland songbirds? By structural recreation, I'm just referring to the actual path structures, so the physical features in the landscape, and functional recreation is like the actual human activity. So to do this, I conducted this landscape scale monitoring study. So I used wildlife acoustics song meter micros, and I deployed them at 96 unique recording locations with a minimum distance of 250 meters apart. So they're picking up independent calls. And I paired this in an experimental design. So I had sites where there was recorders deployed on a path and away from the hiking trail. The recording period was 6 hours of daily continuous sampling in 3 distinct sessions. So around local dawn, a lunchtime recording from 12 till 2, and dusk across the breeding season. So that captured the time and the season where these birds are most active. And there was a lot of data, so we recorded them for a median of 21 days, and that created around 13,000 hours of total acoustic recordings. So, of course, to process this, I needed to use automatic classification. So I used BirdNet, which there might be, can I do a bit of audience participation? Can I see a show of hands for people that have used BirdNet for any? Nice. Okay, amazing. Okay, so we all know what BirdNet is then. I don't need to do too much on this, but it's an AI tool. It's a convolutional neural network which uses these deep learning algorithms to recognize patterns in the sonograms of different species. So it will convert a large spectrogram to a 3-second clip and then run that through and assign it a confidence score for each different species that it thinks the recording has come from. So I ran that with a custom species list for the cairngorms and retained every output above a 0.1 confidence. And that is just our 3-second clip of a wren. So I wanted to take a quick aside to talk a bit about BirdNet confidence scores. So confidence scores are these values that come out, right, between 0 and 1, and they're a kind of new source of detection data in ecological surveys. Whereas traditionally, we would go to a site and record whether a species was present or absent, which is a binary variable, a 1 or a 0. More and more now, our ecological data is coming out as this continuous score, and that has different interpretations. And the interpretation of that is actually species-specific as well. So here is some data from a mini validation study that we did where we extracted 100 detections across a 0 to 1 range for each of these 5 key species and confirmed whether they were indeed actually a true positive detection or a false positive detection. And the main thing I'd like you guys to look at here is that we can get true positive detections at very low confidence scores. So these are genuine detections. It's just likely that there might be more environmental noise or the species is calling far away from the acoustic recorder. Also, the maximum score of those false positive detections varies by species. So when you set these kind of thresholds on these confidence scores, we've got to be mindful of what that's doing. Typically, if a species is there and there's a true positive call, we can get a very high confidence detection of around 0.9. But what this kind of validation strategy allows us to do is actually fit a logistic regression to predict how the probability of confidence being a true positive is related to the actual score. And just kind of to note 2 key things here and show how much this varies by species. For the coal tit, to get a 90% precision, you just need a threshold of 0.3. Whereas for the great tit, which has a much greater call complexity, you need a 0.9 score to get 90% precision. So if you're working with BirdNet confidence scores, I'm doing a cheeky plug for this publication that we just did, where you can scan that QR code if you're interested, which kind of gives a framework for working with artificial intelligence in ecological inference, in terms of thinking about the errors that it's introducing. So we typically have 2 main errors when we're modeling ecological variables. We have detection error, which is actually picking up the species on the device. And now we've also got classification error and uncertainty. And there's 2 main ways we can work around this. We can either threshold, where we collapse our scores into 0s or 1s. So we just pick an arbitrary value, which means anything above that is a detection or anything below is a non-detection. Or there's this novel class of what we call coupled classification algorithms, which actually input the scores themselves. The interesting thing to note is that for both of these methods, some degree of validation, I've realised, is essential. Even when you're using these models that model scores, you need some confirmed detections to actually help the model estimate the true positive distribution from the false positive distribution. So anyone that is working with BirdNet, I would love to chat more about that. But luckily for me, because I have an experimental design in the cairngorms, I actually am able to overcome some of these problems where I can assume that these errors are arising consistently within experimental pairs. So if we look again at this kind of deployment, if we make the assumptions that within these pairs our false positive rates are fairly consistent, we can set arbitrary scores to investigate, or arbitrary score thresholds to investigate the differences on versus off paths. So whistle-stop tour of some results. We detected over 130 identities in these recordings when I set these arbitrary thresholds. And I filtered this to my smaller study community of woodland passerines. These were 26 species that we know exist and live in the forest. And there was a range of species richness that we saw across the sites from 15 up to the whole community of 26. And interestingly, the number of detections showed a great range from just 700 to over 5,000. To mop up habitat variation, I made use of terrestrial laser scanning data. This was data collected by University of Cambridge, and there's 39 metrics of vegetation complexity, which I could run a PCA on to basically summarize the main differences in the habitat variation. And to summarize recreational activity, we're making use of the social network Strava, which provides data on the number of activity events on each linear feature in the landscape. If you multiply that by the path length, you get this metric, which is pretty much explaining how many meters is walked in a given site. And that's just showing the distribution of the raw counts and the more standardized counts. Okay, on to a few results. So I looked at call rates across space and time. So I modeled the number of calls as a function of whether a recorder is on or off the path, the recording session, and some habitat kind of controls and human activity. There's a lot of species that I did this for, so I'm just extracting a few key ones that we might know about. So here's the wren, and what we can see, as we may expect, there's a very significant effect of recording session on the number of calls that we are detecting. But interestingly, what we can see is that the difference between kind of on-path and off-path call rates does vary by the time of day. So it's not significant for this species, but what we can see is that there is significantly more calls further away from the path in the lunch, right, in the busy kind of human activity periods. This is just extracted for some sensitive species living in the region, the tree pipit, spotted flycatcher, and song thrush. But the key takeaway here is that there is very species-specific responses in how session and like kind of path effects affect these different species. Okay. So a bit of a take home then. Cairngorms, we detected a very diverse study community, and this passive acoustic survey actually picked up species that we didn't know were living there or haven't been detected for a long time. And from this kind of preliminary analysis, we can see that the responses in space and time to paths and human activity is very species specific. And these initial results do suggest that humans are having effects on fine-scale call rate behaviour. Now, call rates might reflect abundance, or they might just reflect behaviour of species that are living there. Our next steps is looking at community modelling to investigate how this is actually affecting the interaction networks of these species living in different sites. Okay, so I see it says 0 minutes, so I'll end here for questions. But yeah, there's a summary behind me, and yeah, I welcome any questions on anything that I spoke about. Thank you.
Thank you very much. So do we have any questions?
Hi, thank you. That was really, really interesting. You were mentioning the LiDAR. I'm working with LiDAR as well in a very different context. So would you mind explaining that a little bit more, what that means with like how they, I guess you said you have that to find out the different type of vegetation?
Yeah, exactly. So basically what I wanted for this model was what I call a habitat mop, where I basically just wanted to account for any kind of variation in habitat effect. So LiDAR, for those, I think probably most people know what LiDAR is, but I'll briefly explain it. It's a terrestrial laser scanner which fires basically a laser beam and can reconstruct 3D models of habitats. So what this postdoc did at Cambridge was took these point clouds and actually generated 39 different metrics which represented things like canopy skewness, height of ground vegetation, standard deviation of the heights of vegetation in different brackets. So there's tons of metrics that basically kind of reconstruct what it means in terms of the variation of the habitat in a certain site. And obviously that's way too much to put in a model, which is why I ran this kind of PCA on it, which basically means I can summarize all of that variation with just the first two principal components. I think I had, so what we can see here is that when we get to metric 39, we're not actually summarizing any more variation in our habitat. So we don't need to put 39 covariates in our model. Ideally, what you should be aiming for is around 90% explanation, but because I have a fairly small data set in the Cairngorms, I decided that around 80% was good enough. So that's how I could kind of summarize all of that habitat complexity into just 2 covariates to use as a control almost. Does that answer your question? Yeah.
Thank you so much. It was really good. I have a question because you mentioned the number of calls that you detected with BirdNet. But so how did you do it? Did you actually modify BirdNet a bit? Because for me, it detects overlaps. And it's more detecting like, okay, there's a call between this second and this second, but it's not telling me there's this amount of calls. So I wanted to know, how you did that.
Yeah, good question. And this took me a while. So BirdNet will obviously assign an identity to a 3-second clip. So initially I was just working with the number of 3-second clips above a certain threshold that were detected for each species. I had obviously really bad temporal autocorrelation in that data, so none of my models were working, and it took me a while to figure out why. So what I ended up doing was just saying that I kind of binned my data into 1-minute intervals, and I would count a call in 1 minute if there was a BirdNet detection above that threshold. So basically, the count data is actually, if we go here, this count data at site I at time j is basically the number of 1 minutes that a species was detected in an hour-long file. So it's a bit of a workaround to kind of overcome some of that correlation in the data. But that means that when I look at this data, it probably doesn't, it's a measure of relative abundance, right? Because I've done it the same way for all the sites. But translating that count into an actual number of animals is impossible in this framework.
Thank you very much. It was very interesting. Just a question. It's just another part, but can you correlate your activity with abundance of birds? Because it can be difficult because you have an activity, but did you maybe some future application, something like that, to cross the abundance data of observers or something like that with your activity pattern or something like that?
Yeah, so getting abundance from acoustic data is very difficult, as this chap in the front will know, because he's doing his whole PhD on this. But basically what you need for example, like an N-mixture model, which is trying to estimate abundance from repeated count data, is quite strong assumptions about individual identities. So if I knew like my individual calls, I could do this. With the framework that I'm working where it's just number of counts of a given species, I can get some relative metric. But that's kind of all it is. I think to translate the actual calls back to the number of animals, I'd have to go into the field, have some kind of understanding about the number of animals that are making a certain call. But if I looked for data on the actual call rates of species, I could then say, okay, well, one animal makes this many calls in an hour, and therefore I can try and extrapolate that up. But I'd be a little bit dubious about doing that in this context, because I don't know if it would be that accurate. But I think it would be possible with that kind of framework. Yeah.
Thank you.
Okay, really.
Thank you. How might the national park people managing use your results?
Good question. So what we're kind of trying to work out here is, what do birds care about most? Do they care about where paths are placed, or do they care about how often paths are used? What we could see from our pilot study, which was done in another forest in Scotland, is that actually the main effect of kind of recreation on birds was structural. It's more that when you put a path in a certain location, certain species will move in and stay there, and other species will move away. So looking at this, we're kind of thinking about differences more in behaviour. I think it's, when it comes to woodland passerines in the Cairngorms, the park doesn't really know, if they care. And I mean, we don't really tend to know if kind of these smaller songbirds that are actually nesting quite high in trees do care about people. So there's these general consensuses that recreation is negative for them. But we're trying to work out what effects does it have for their kind of actual community structures. So once we've done that community model, we'll be able to better understand what that is, and then I mean, obviously with the right to roam, you can't restrict access, but you can put signage out to, you know, encourage people to act differently in sensitive times, for example, in the breeding season. And that is done for my favourite species, which I would like to end on, the capercaillie. Thank you.
Hello everyone, my name is Raphaël. I doing my PhD in Avignon in the south of France. My works focus on the use of passive acoustic monitoring combined with deep learning to study bird ecology in an agricultural context of apple production. So to begin, as you all know, biodiversity is undergoing a massive global decline and birds are not spared. Agriculture is identified as one of the key drivers of this decline in Europe. In this context, there is a need to continue documenting the factor influencing birds' community and population in order to develop appropriate management measures. For that, passive acoustic monitoring, defined as the collection of acoustic data using an autonomous recorder, offer new possibility to study vocal animals like birds. This type of data acquisition has several advantages compared to a traditional point cloud survey, but the biggest one for us is to conduct a large-scale temporal and spatial monitoring. However, due to the large volumes of recording, it's manually impossible to identify bird species in all of them. To address these issues, the recent emergence of deep learning-based algorithms such as BirdNet offer great opportunities. BirdNet is an algorithm able to identify more than 6,000 bird species in acoustic recording around the world. Specifically, when a recording is processed by BirdNet, it generates a list of detection, including the identified species, the time of detection, and the confidence score. This confidence score ranges from 0 to 1. The closer is it to 1, the more reliable the detection. However, the reliability of this score varies between species. Currently, the majority of studies working on BirdNet are focused on one end, comparing BirdNet results with traditional point cloud survey, and on the other end, trying to maximize BirdNet efficiency by setting a species-specific confidence score threshold to answer a certain percentage of correct identification. However, few studies have attempted to use BirdNet in concrete case studies, raising key questions on how to use concretely this tool to study bird ecology with the objective of identifying factors influencing birds' community and population, and how to minimize biases that can influence bird detection. To answer this question, we start from a concrete case studies with two objectives. One, to propose an analysis pipeline that accounts for biases potentially affecting bird detectability and BirdNet performance. And two, to test the usability of three different metrics derived from BirdNet's data that quantify an intensity of vocalization at community and species scale, and one which is very used in community ecology, the species richness. To meet this objective, we collect acoustic data using SM mini recorders in 60 orchards in the south of France, in the south of Avignon. To test our metrics, we choose to compare two management types that are well known for structuring birds' communities. We include both organic orchards, where the use of synthetic pesticide is prohibited, and conventional orchards, where the use is allowed. All plots were recording for 2 weeks, one between mid-March and mid-April, and one between May and mid-June. Now I will present you the different filtering steps we apply and recommend to conduct analysis based on BirdNet's data. So the first step was to clean the raw data by keeping only good weather day. After that, we can run BirdNet on the standardized data. The first challenge here was that BirdNet detects a very large number of species, including error and transient species. So a key step here was to define a list of 34 bird species likely to breed in the study area based on previous studies and regional species checklist. Now we have a dataset containing the detection of our target species. However, this dataset may include BirdNet's error. So the next step was to filter this dataset to answer a satisfying level of accuracy of our detection. For that, I listened to 100 Burnett's detection for each 0.1 confidence score interval for the 34 bird species and annotated them as true or false. Using this result, I applied the method described by Barrett 2019, which drove fitting linear models with detection validity as response variable and confidence score as explanatory variable. This allowed us to calculate for each species a confidence score threshold answering a 90% of correct Burnett identification on the final dataset. We then filter the original dataset by this species-specific confidence score threshold, and now we have a final dataset containing the detection of our target species with 90% of correct Burnett identification. From this dataset, we can start thinking about which metric can be used. The first metric we used was Burnett detection number per plots at 2 scale. At the community scale, where it's considered like the community activity density on the plot, and at the species scale, where it's considered like the activity density of the species on the plot. So first, at the community scale, we observe a strong variability between orchards and seems to be consistent with our initial hypothesis, with more detection in organic orchards than in conventional one. In addition, a correlation was found between the detection number and the ACE, an acoustic index commonly used to describe birds' community vocal activities. This result suggests that this metric could be a good and fast proxy for the community vocal activities, with the advantage compared to a synthetic index of allowing us to identify which species contribute the most to these activities. Same result was found at the species level. We observe a strong variability between species vocal behavior, and results were coherent. For example, for various measures, we found stronger activity in organic orchards in adequation with all the precedent studies, which show more individual of this species in this type of orchards. Finally, a common goal in community ecology is to obtain synthetic metrics. Among these metrics, species richness is one of the most used. So here you have the richness value of the different orchards. As you can see, it's quite stable, and most importantly, the vast majority of studies of species are detected in all plots. In reality, previous studies using point count survey show an average richness of about 9 species in orchards. This difference can be explained by first potential Burnett detection error, but also by the long duration according and the relatively homogeneous distribution of species across the study area, making it very likely to detect each species at least once on all plots. To obtain a richness more representative of species that actually use the plot during reproduction, we try to implement a posteriori filters that aimed at define a detection number threshold to try to keeping into the richness of a plot only species that actually use the plot during reproduction, and to exclude Burnett's error and punctual detection. Here you have the result for one of these filters. As you can see, the richness value decrease a lot, bringing them closer to those found with point count. However, looking in detail, it appears that the different filters we set up have very species-specific effect, and the inclusion or exclusion of species of the richness of a plot was largely driven by the species vocal behavior. So this result suggests using Burnett for the moment, it's very difficult to answer a reliable list of species that actually use the orchards during the production. And in conclusion, Burnett can be a useful tool to study factor influencing birds' community and population. However, particular attention must be done on the metric used, and these metrics must be in adequation with a new type of data generated by Burnett. And just to open, given the high temporal resolution of this method, growing opportunities are emerging for studying birds' phenology, both at daily and annual scale, two aspects that I have and I will address in the following chapter of my thesis. Thank you.
Do you have question?
Thank you for your presentation. It was very interesting. Did you try to computate different indices except from the acoustic richness. Why did you choose this one?
We chose species richness because in community ecology is the most used, so we want to use precedent studies and to compare with precedent studies, so we choose this matrix.
Okay, thank you.
Thank you. Me again. Ivan. I have a question about your conclusion about BirdNet estimating richness. So, if I understood well, the BirdNet is bad to identify species richness, but is it good for relative richness? Like compare two sites. If it's a bigger richness than another.
The fact is, the first richness metric we calculate, so in the left, if a species is detected at least once, it's considered on the richness of the plot, but ecologically, these results have no sense. We detect all species on the orchard, and we know that it's not possible to have all the species which will do zero production in the orchard, so we can't work on this richness value. And if you look the application of filter change the relationship between organics and conventional orchards. Here we have more species on organic orchards, and with the filter this relationship change, so it's very dangerous to use this metric, I think, for the moment.
Even for relative richness? Okay.
Yeah.
Thank you.
Thank you. That was super interesting. And one thing that struck me is that you probably, because of your validation, right? I guess you have known species richness because you have confirmed detections of each species across, where you validated each range. Did you do that for all the species? Because then I guess it could be really interesting to look at your actual, how the detection number thresholds change that relationship according to what you actually know in each site.
If I understand, if your question is if I check on the richness here, each species, if it's a correct detection?
Yeah.
No, but looking at the data, it appears that for every species we have a lot of detection, and we have the filtering on 90% of good answer from BirdNet. Yeah. So it's very probable that we have true detection on this richness value for each species.
Thank you.
Thank you so much. It was really good. I'm wondering about your like the a posteriori filters that you used, and if you could describe this a bit, and if you can also speak a bit about whether or not it was possible to, for example, say, okay, if a bird is singing every day during the dawn chorus this amount of time, detected this amount of time, then potentially, it could be breeding there, or if you didn't do that.
First, for the dawn chorus, we conduct an analysis on bird phenology after this work, and we have a lot of species that use the orchards, but not during the chorus. So I think it can't be possible to just consider species that detected in the chorus. And for the filter, initially the first filter we applied, we want to exclude punctual detection, so we put a general filter of 10 detection, and species detected less than 10 times were excluded from the richness of a plot. However, due to the difference in vocal behavior, for example, for Erytacus rubecula, we have orchards where we have 4,000 detection. So when we have 30 detection, we can consider that the species not use the orchards during reproduction. And with the 10 detection filter, this species were maintained in all the plots. So we try to implement a second filter which aim at adjust this detection number threshold by the vocal activity of the species. But the effect of this second filter was very different between species, and it's very complicated to work with it.
Okay, so for me, thank you for the presentation. Do you plan to thanks. So do you plan to pair your results with active listening from experts in the field, and especially to go further to the selection of your filter, and especially for the species richness?
No, we don't plan to do active listening, but we compare our result with precedent studies which use the point count survey, and for the moment, the conclusion on richness is that we don't think it's possible to find filters that account for the big variability between species vocal behavior. So we finish on this filter, and now I work on phenology. So
Okay, thank you very much. Okay, hi everyone, and to start now again, we will welcome Olivier Fan, and he will talk about the impact of road noises over alpine soundscapes.
So, hello everybody. So, I've just been introduced. My name is Olivier Fan, and I'm pleased to present you the results from work about evaluating the impacts of road noises over alpine soundscapes. So, as a personal background, I'm a graduated engineer, and I've been working for 5 years in as an acoustic consultant. And this year I decided to make a shift in my career and work as and joining the International Master of Bioacoustics in Saint-Etienne. And it's very sensitive. So in my case, I will talk about soundscapes. So I'm so very sorry. I need my notes because anyway I will try to do with everything. I'm sorry. So as I was saying, in soundscape analysis, soundscape they can be described by their sources, especially. And in this presentation, so in my case, I'm focusing about how technophonies, as part of anthropophony, will affect the biophony itself in the alpine soundscape. As road noises, which will be the focus of my study, I will focus on two types of noises, which are the traffic noise and the engine noises. So the first one is more about a whoosh noisy broadband below 1,500 Hz, very similar to a constant wind noise. And the second one is the engine one, which is the engine noise, which is mechanically driven by the engine's rotating speed. And yeah, as you can see, it's very harmonic, and the fundamental frequency starts below 100 Hz, so very low one. Other road noises, they have been like rolling tires and honks, they have been a bit put aside because there was less detections in the studied soundscapes. So road noises, effects of the road noises have been studied for a while now, and there is some effects on at different scales, so at the proximate individual responses, such as raising the song level, for example, for nightingales, but also at the ultimate individual response scale, with a change in I don't know how it works, this one. Like, it really feels like it's going flying. Anyway, with the change also in reproductive behavior, especially for frogs and toads, and even at the ecological level, with ecological effects, with altering the seed spreading also. And road noises, they are also affected by an increase of of the daily traffic, as you can see, with an increase especially in the traffic of motorbikes, up to 15% if we compare to the 2019 level. And we can expect also that due to the specificities of meteorological factors and topographical factors, especially low frequency noises, they can travel way further within the mountains. Which leads us to this question: how far road noises affect the alpine soundscapes? So, and how we can detect it. So our study case is the Hors-Champ Sound Project, which is a large multidisciplinary observatory. In my case, I'm focusing on the recordings that has been done in five locations within the French Alps over 24 plots. So we take at different altitude gradients, more or less away from roads, so this will be our study case. The first part will be was to annotate everything, or at least stratified sample subset, so over plots, month, and daytime. And it represented 1,100 minutes approximately, so 18 hours and a half. And when we look at that, so the annotation was focused on the abiotic events that happen below 1,200 hertz. So since we are in the low frequencies, the window size is quite huge to compare with when we are annotating birds, for example. And my focus was especially with the roads, and as you can see, in fact, there is way more engine noise and traffic noise than honks and tires rolling, at least detected, I mean. So when we compare, so if taking those data, we are taking, I was taking a comparable metric for every plots to make, since like the detection time was, the recording time wasn't the same. So we have this, the rate of the road noises detection time per site. And this is the outcome. So we have up to 60% of recording rate of road noises at some places. And when we compare them with the distance to the closest road, so we have there is a lack of a little regression line. I know, like everybody tells me that I will do it one day. But what's quite interesting is that the distance to the road that can reach the road noises is like about 5 kilometers, which is way that far. And if we consider just the geometrical decay of the road noise of any source point, 5 kilometers should be a decrease of 54 dBs. And if you take an average engine noise at 10 meters of 72 dBs, it should be 18 dBs in the outside, which should be masked by anything else. So there is something going on. Is it representative of the many minutes? And this is all the question that has led my 3 last months, how to make it, how to extend this detection outside of the subset. So manually annotated is not reasonable, definitely. I mean, it took me like a week for 1,000 minutes, and there is 150 more. We could also have a look at the acoustic indices, but as you can see, so here we have the calculated NDSI, the NDSI shows high variability, as you can see on the jitter plot, but also looking at the median level, it looks like geophony has a way bigger effect than the road noises on the decrease of the NDSI. And even when we are looking at the road noises over a comparable event, it looks like the NDSI is increasing, which is absolutely counterintuitive. Intuitive. When plotting a clustering analysis, it looks like there is no cluster happening, like at least standing out from the other soundscape neither. So it was not neither an option, which led me to the environmental sound classification strategies. So first, I had compared like 5 different sound classificators. The first one is a fine-tuned version of Burnett, which I call Vroomnet, as a car, like yeah. Anyway, second one was Connet, which is a captioning zero-shot captioning algorithm, so which gives a sentence of 20 words describing soundscape, which led me to like semantic analysis and everything. It was a bit complicated. Another tool, another zero-shot tool, which is CLAP, so MS CLAP. Maybe you heard about this one. It's a contrastive language audio pre-trained model. So giving 2 sentences, it will give you a probability score of where what sentence matches the most with the soundscape that you make listen. And 2 other custom classifiers. First, a random forest one from audio embeddings, the audio embeddings of claps, and finally, neural network that is done for image reading. And so I used the ResNet 18 from the parameter spectrogram, and it's the only one that actually you can have the control over the entry spectrogram. So for this, I've been focusing myself on the engine noise only. So it's definitely representative of the annotated road noises. Even yeah, as you can see, and it's also more easily detectable on the spectrogram with the all harmonic stuff. And this is the result of my classifier benchmark. So I've optimized the F0, the threshold has been set to optimize the F075 score. And we can see that the ResNet 18 outperforms by far the other ones on this base. And when we are comparing the results from the manual annotations, so on the left, and the ResNet 18 detection, we have definitely a conservative response for the detections of the ResNet 18. So less detection, but still, we still have this information, which was key for us, that road noises were detected at 5 kilometers also. So I will be able to use ResNet for a larger detection within the full data set. And on the conclusion and the classifier, well, about the conclusion, so yeah, ResNet 18 outperforms by far the tested classifiers. There is still a bit of a risk of overfitting though, but the control of the entry spectrogram is, it appears that it's definitely the most important part for this detection. So what's next? Well, I would be happy to discuss it with you a bit later. And thank you for your attention.
Question?
Thank you for your presentation. I have a question on the types of engines you matched. How did you make the difference between like road vehicles and ULM or plane engines? Or did you make a difference?
So yes, in fact, there was especially like aircraft noises. Most of the time, aircraft noises they're also accompanied by a very long whoosh. Like they are way longer in the occurrence, less sensitive also to the changes in rotating speed of the engine as well. Like it, well, yeah, it's something that was definitely identifiable on the noise.
Thank you. It was a very interesting talk. I got a few questions, but I'm gonna ask just one right now. Just for the ResNets, I guess it was pre-trained on something like AudioSet. Do you know with which one? Or
It was absolutely not pre-trained on the like it was like absolutely fresh this one.
Okay, right.
And so what I did is like from the annotated data set, I split it into like some half of the plots were dedicated for the training and testing, and the other half is the result that you've seen. So there's less dots, and so this is where I said that there might be a risk of overfitting, even if like plots were dedicated. Like so, it's one recorder was not used for both training and validation.
And for the embeddings, did you use those of BirdNet or of which ones?
I used the one of Claps, which is the HTS-AT transformer. It's like a 512 audio embeddings.
Do you know if at those frequencies some species might be affected by the low frequency noises? Because I know in marine soundscapes they can.
Yeah, I mean, well, my colleague right here, Corentin, who is gonna give a talk. Like, for example, we talk about the common cuckoo, and the common cuckoo, like, its goal is more around. I don't know exactly. Can you remember around? Well, it's still in the low frequencies, and it's definitely overlapping these frequencies. And it doesn't mean neither that they can't be affected though by the. It needs audiometry. This, but yeah.
And can I ask another question? Or yeah. Do you plan on see if there are impacts on, like, now that you've detected the road noises? Do you plan on seeing whether there is impacts or not?
I would love to do ecoacoustics. Yeah. My plan is not especially on birds. Like like I have to admit, my heart goes to the marmota, and then I also like retrain BirdNet to detect marmota, and I would love to make like cross detection to see if there is an impact, of course.
Thank you.
I go. Okay. Hello everyone. So I'm Johan Roulet. I'm a PhD student working on in a laboratory in Brittany, Brest, in France. So I will present you a study that we are making concerning assessing effects of park night lighting on green urban areas communities using passive acoustic monitoring. So this study is made by also with my supervisor Sébastien Gallet and Xavier Dauvergne. So as introduction, there is a growing concerns about artificial light at night, and I will refer as Alan for concise purpose effects. So since 20 years, so it's not so far, there is more and more knowledge growing about artificial light and night effects, and there is some paper here working on it. So now light is largely accepted as a new kind of pollution. And this pollution, this light pollution, as we can mention it, is affected a wide variety of taxa, whether they are marine species or terrestrial species, or diurnal or nocturnal. So it's a lot of species, and at a different level of biological organization. It can change gene expression, in example, it can change behavior, populations dynamics, with fecundity modification, communities compositions by deleting some species and bring others, and changing traffic interaction in example. So it's just little part of the effects of light pollution. Nevertheless, there is a lot of knowledge, but it is still a lot of to go further. And in 2021, Franz Solker and his collaborator wrote a paper about it, with identifying 11 pressing research questions on how light pollution affects biodiversity. Concerning consequences for biodiversity, they identify the need to go further into community scale studies and especially at ecosystemic levels. And concerning bending the curve of biodiversity loss, they identified the urgently need to go into opportunities and challenges for an effective management for conservation purpose. So in my thesis, in our project, we want to answer a question between others, but one of them is, does part night lighting affect green urban areas communities? Because part night lighting is a common management practice, but there is not so much literature on it. And we have two general hypotheses that we want to test. Switching off the lights could increase species richness by promoting species that are not strictly nocturnal, or maybe bringing some dark and bring some nocturnal species. And another hypothesis is switching off the light after 11, an example, could increase the activity of nocturnal species and decrease that of crepuscular and diurnal species, like dawn couriers and birds that can be more active with light, whether it's even if it's night or not. So to test it, we studies took place in three territories in France. So Brest Métropole, where I live, it's easier. Communauté urbaine de Caen-la-Mer, it's harder. And communauté d'agglomération de Maubeuge-Val de Sambre, it's even harder. So it's three territories in the north of France. It's urban territories, and we compare sites with switch of that green urban areas with switching off light, outdoor public lighting, and others that will with no switch off, so with full night lighting. In each territories, there is we selected 6 sites for their comparabilities or the same site regarding landscapes and other parameters. So 6 sites in each territories, 3 with full night lighting and 3 with part night lighting on each territories. So here is Brest, Caen, and Maubeuge. Concerning our protocol, we want to assess the acoustic and taxonomic diversity. It's our goal in each site, comparing full night lighting and part night lighting. And we monitored between April and August more than 120 hours per month continuously. We applied a sampling rate of 48 kilohertz, so it's an audible sound for human. And we applied the gain, no triggering, continuous recording. It's a common things. And we expect more than 10,000 of hours of recordings and more than 4 terabytes of data. It's a lot for us, at least. So here is the preliminary results. Sorry. So here is the case for Brest Métropole during April 2024. It needs a lot of future investigation, but we tested 2 indexes. So we talked about NDAC just before. We talked about ACE. Here is both. So NDAC is for normalized difference soundscape index, and it's just an index that compare low frequencies for corresponding more to anthropogenic sound, and high frequencies above 2 kilohertz more for biophonic sound. It's more into biophony, so it's an index that is useful for check the part of biophony and geophony in some soundscape.
And the ACI for acoustic complexity index, it just an index that measures complexity, the heterogeneity of sounds, depending on frequency, amplitude, frequency, etc. So we compared the site with full night lighting and part night lighting, and we split our data between 4 periods. It corresponds to astronomic period. Astronomic period, it's for example the dusk astronomic period. It's when the sun goes below 18 degree below horizon. So it's a perfect night, no influences of sun at all. It's astronomic period. So 4 period, down, day, dusk, night, and we check the indexes value. So what we can see concerning these results, at least this preliminary result for one site during April, is that concerning the NDSI, for part night sites, the NDSI is lower at dusk, night, and dawn, significantly with the Wilcoxon test at least, and at day it's higher. So one hypothesis that we have to check is maybe it's there is a more polluted site more polluted site at day for the sites who are enlightened full night, but at night the part night I have to to recheck that. Yes, at day there is more. I will arrive. At day there is more biophony sounds than at night, dusk, and dawn. So maybe it's due to more if there is more light, there is more biophony. It's as simple as that. Maybe we have to check the other environmental factors. And concerning the ACI, there is less complexity at night, but more at day. So maybe it's just an affair of nocturnal species composition in the community. So we have to check the communities and to see the nocturnal species. So there is a lot of future investigation and not so much time, but so we want to assess total acoustic diversity using indexes like NDSI, SCI, and compare before and after switch off during the night period, evaluate the influences and interaction of other environmental factors, evaluate the noise pollution impact too, and we want to assess taxonomic diversity using Burnett between others, and assess environmental factors, influences and interaction, and noise pollution also. Thank you for your attention.
Questions?
Thank you for your very interesting presentation. You said that you were filtering at 48 kilohertz or recording at 48 kilohertz. So you don't have most of the bat species in your spectrograms. Is that you wanted to exclude bats from your study?
Yeah, when you yes, it's a matter of data management, etc. When you work with higher sampling rates, the files are so much weight on files. And yes, we focuses on audible sounds mainly. It's just a compromise to the species focused and the data management, etc. So it's more into something like that. And for bats, it's not the same kind of protocols. If we want to focus on bats, we have to adapt the protocols too. An example, it's in the other part of my thesis, we sampled the same site. We put it some audio mouse with case. It's not a very good idea, but we tested it, and so it's with higher. I don't remember the sampling rate. It's very higher, and it's just 12 nights with good weather, etc. To have to assess the activity and the community, and I think it will correspond to the same. We will have maybe 4 terabytes also with just 12 nights. So we have to adapt the protocols to with data management, data evaluation, etc.
So I have a question to join your questions. So if you exclude bats, what community of animals do you focus on? Only birds, or also mammals that can do some cries, social cries, and also because at the audible level you can also have bat calls. And yes, how do you plan to manage this?
Yeah, in fact, we will primarily focus on birds because there is a lot of tools, even if there is a lot of limits, but there is a lot of tools. And we will primarily focus on birds, and we listening the sounds. It's the major party of the major part of the soundscape is due to birds singing in calls. But yes, I hope to explore also the effects of orthoptera, grasshopper, etc., and maybe small mammals. But it's more into we will see how it can be done and what tools we can use to do it, and etc. But maybe we will not have time. We will not have the capacity to do it. But it will something that I'd like to check.
Thank you.
Yeah, thank you very much for your presentation. So you used you measured on 3 sides your indices, and after you averaged everything. Like, have you concerned any potential variation from one side to another? One side to another. Any variation of the mean NDSI or something like that per day?
For each site?
Yeah, I mean, if there is an identifiable variation between sides of the three, like, I mean, it's not relative to each site, I guess.
Yeah, I see. If the differences can be due to sites differences more than into like switch off something like that. Yeah. It's something that we will do in the future investigation to see how the variation of the indexes, what can influence the heterogeneity of the data, and what are the factors. If it's difference between sites, size of the sites, landscapes. If it's I don't know, maybe weather. That even if we try to control these parameters, maybe it's there is tiny things that we forgot, and there is weather impact, something like that. So yes, it will in future investigation.
Do you have short question? No. Oh, me. Yes, in your sites, do you have watch if your part night sites are more urban or less urban than the other?
Yes, the selection of the site was a lot of work because to be sure that there is no so much landscape due to landscape variation. So yes, we made a landscape analysis to see the proportion of urban area, grassland area, tree area, etc., to have the same heterogeneity and the same proportion of impermeabilized area. So yes, it was more into the selection of the sites, this part. But we will control it because there is a lot. It can change between sites, but we try to control it at the selection of the sites step. That's why also because we have not so much sites. Also.
Okay, thank you.
Okay, now welcome Corentin Bodson.
Thank you. I don't know how to use it. Okay, so I'm really happy to be here with you. So many beautiful people. So my name is Corentin Bodson, and I will present to you some of my results from my M2 internship with Camille Desjonquers at the Laboratory of Alpine Ecology. which focused on the mismatch and asynchrony of alpine birds in the context of climate change. So mountains are highly vulnerable to climate change with changes that are elevation dependent. For example, we have a faster warming in higher elevation and faster increase in precipitation at the foothills of mountains, which leads to upward shifts of isotherms and disruption of hydrological cycles. And this is what we see in the European Alps, that warm faster than the rest of the northern hemisphere, with a warming that is associated with a loss of glacier, as you can see here with two French glaciers that have lost up to 93% of their surface over 45 years. So species that inhabit these ecosystems can react in different ways. For example, by shifting their spatial distribution to higher latitudes or higher altitudes, or adapting their activity throughout the year or throughout the day. And these responses are species dependent, which could lead to a disruption of co-occurrences spatially and temporally of interacting species, such as birds and butterflies, or plants and their pollinators. This could lead to reproduction and survival issues that could cascade down to communities and ecosystem functioning. To study these phenomena, we need a large multi-species datasets that are repeated in time and over long periods of time. And collecting such data is quite limited in mountains due to the complex topography, and this is where we can use passive acoustic monitoring to follow the activity, the vocal activity of species continuously and simultaneously across multiple species and even in some remote areas. So I used PAM to study how climate change could impact the phenology and co-occurrence of competing bird species in the French Alps. I first looked at how this activity was structured across space, and here mainly altitude. What environmental parameters could explain the distribution of the acoustic activity, and I'm still working on it, but which potential mismatches and asynchronies we could see in the future compared to now. So I focused on 9 species of birds that all feed on insects and have different morphological characteristics and different migratory strategies that could impact their response to climate change. To study them, I had access to 1-minute recordings that were taken every 15 minutes over the whole period of May to October 2022, thanks to recorders that were placed at different altitudes in the French Alps in the context of the Orchamps Observatory presented by Olivier before. So this created a lot of recordings that we passed through a pipeline containing BirdNet, which returned a prediction for the species heard in the recording and a confidence score, and which wasn't usable as is and not transferable between species. So I validated a subsample of recordings for each species that allowed me to determine a threshold above which I kept recordings, considering they were correctly identified by BirdNet. Then I divided the activity into 3 metrics. First, the abundance, which was basically the number of recordings during the day in which a call was detected. So here you can see the distribution of calls for the common cuckoo. Then I computed the weighted mean dates, which I will call WMD, and which weighted mean hours of call occurrence for each species and site. And here you can have an idea of the global WMD for the common cuckoo. Then I linked these 2 first metrics to altitude and environmental factors extracted from high resolution array analysis with using linear models. And finally, I computed distribution overlaps between pairs of species, but I used it more qualitatively for now. The first result that we saw is that when looking at the weighted mean date of occurrence of calls, depending on altitude, there was a significant positive relationship mainly for sedentary birds, such as the alpine accentor, the Eurasian bullfinch, or the Eurasian kestrel, which means that they call later in higher altitudes. And this could be potentially explained by a high sensitivity to temperature levels, to temperature variations. As you can see here, for example, with the alpine accentor that is strongly negatively impacted by temperature. So this is the sensitivity of abundance of calls to environmental factors. And there are significant but more moderate sensitivities for the other birds for temperature. And the difference between sedentary birds and migratory birds could be explained by migratory birds relying more on environmental cues on their wintering grounds, or other environmental factors like photoperiod, as you can see here for the common cuckoo. These sensitivities were species dependent, which could lead to potential mismatch and asynchrony between interacting species, for example, like the alpine accentor and northern red here, which are highly co-occurrent in their spatial distribution, but also highly synchronized. And the alpine accentor is way more sensitive to temperature, and so it could be decoupled with the northern red here. The next steps of my internship will focus more on the spatial aspect of this acoustic activity using SDMs, so species distribution models. And what I will do is take environmental data and the activity points from my recordings and pull them together, pulling time-specific environmental data with the corresponding presence or absence points, which could help me to produce models, correlative models, to create maps of habitat suitability for calling activity. And then I will integrate classic species distribution models to determine where the species are supposed to be and where they could sing at the same time. And so I will focus on which integration method I could use. There are several ones. For example, I could use the potential species distribution from my classic SDMs to mask the habitat suitability for calling activity, but it's not really the best here. And a better way would be to use a more Bayesian approach, for example, blending together habitat suitabilities both for calling activity and for species presence. And as you can see here, we have less sharp edges for the distributions, and it is more mathematically correct and ecologically correct to do it that way. And a last method that I could use is use the output of my classic SDMs as a prior that I will put as an explanatory variable in my models to create the acoustic habitat suitability. So doing this successfully will help me to combine the spatial coverage of classic SDMs and the ecological and temporal coverage of the acoustic data to better understand large-scale mechanisms and patterns of phenology now and in the future. And of course, now it's not presented, but I'm planning to like project the activity in the future to see the changes compared to now. Thank you for your attention.
Questions?
So my question is kind of about, you mentioned mismatches and asynchronous, and I have a guess what you mean by that, but could you maybe explain again what exactly you meant?
Yeah. So mismatches were basically when species used to co-occur at the same place, but aren't anymore, so there are less overlap in their spatial distribution. So here, for example, we have differences in shifts in bird and butterfly distributions, and this could be an example of what could lead to mismatches. And for asynchronies, it's more when species are together in the same areas, but are not active at the same time anymore, while they used to in the past. So here, for example, with the pollinators and plants, I don't know if you can see here, but pollinators have their peak activity earlier than the plants during the year. And so this is a kind of asynchrony. But asynchrony could be either during the year or during the day.
Thank you.
Hello.
Hello.
Nice presentation. I was wondering, you said you chose 9 different species to focus on. Is there any specific reason on why those 9 species? Are they the most abundant in your areas?
Yeah. So the first constraint was that it's a subsample of species from a larger set for a project that is not yet done, but which aims to study the co-occurrences and synchronicity of species of birds and orthopterans they feed on, and so investigate both competition and predation. And so this is why we concentrate here on birds that feed on insects. And I chose these 9 out of the 20 larger set because they were the easiest for me to identify, and also because they had different migratory strategies and different traits that could impact their responses.
Seems reasonable. Thank you.
Other questions? Okay, thanks.
Thank you.
Welcome back. So we are going to hear a bit about yellowhammers from Min Kwak. So
Thank you. Hi, I'm Min. I'm from Prague, Charles University in Czech Republic. And today I'll talk a bit about my first chapter of my PhD, which is about the song individuality and the distribution of yellowhammers. So just a brief introduction about my species. So they're a very common passerine. I think some of you will be quite familiar already. They're usually mostly sedentary, including the population in Czech Republic and the Central Europe. And they're very territorial during and even like after seasons, so like for multiple years. And they're actually a very nice study species to study the geographic variation because of their like distinct songs. So I hope the sound works. Yes. So as you can see, there's like two parts of the song, like where we call the first phrase, which is more the rhythmic trill, and the second part, which is more like a long 2 whistles, which is the dialect phrase. And the dialect phrase is actually quite already well studied, including like from the previous study from our team members from a citizen science project, we managed to identify what kind of types are distributed and how it is distributed in the geographic scale. And as you can see, it's like what we call like a mosaic-like distribution where it forms like patches, and within the same patches, they usually sing the same type. Unlike the dialect, the first phrase is a bit less studied because of their high variability. So basically, one male can usually sing like up to 2 to 3 types, where we call it the repertoire. And this repertoire is, although it's quite variable, it's quite stable through time. So if you see this blue box, one male would only sing the 3 type for like multiple years, which actually helps us identify which male it is just by their songs. But even though the whole combination is variable, there's sometimes like these same structured phrases that are shared even between different males, which we call the shared phrase. So for my study, I focus on the shared phrase types and how it is distributed through the geographic scale. First question was, does it really have a correlation with distance? So are there more shared types when they're like closer distances? And second, does it have a relationship with the dialect distribution? So for the study, I used 2 different types of data. For the larger scale, we used citizen science data, which was collected like 10 years ago, but it was quite well covered along the whole country of the Czech Republic. But I only extracted like some of the data where, of course, like the quality was visible enough for me to extract the first phrase structures. And for the close distance, we had data from like these 2 localities. First one is in Czech Republic, Vyžina, I'll call it as VZ for now, and one in Poland, SW. And here are the sample sizes for each locality. For the analysis, first we quantitatively analyzed the song structures where we used a program called Lucinia. I'm not sure, does anyone know about Lucinia program here? Yeah, you're from Royal Holloway, so it makes sense. Yeah, it's a program developed by Robert from Royal Holloway University, UK. And it's a very powerful program when you can actually manually draw in the wanted signals within the recordings, like you can see. So for our data, where we use assistant science, it's really useful for like overlapping noisy signals, and we can really extract the acoustic parameters from these designated signals, even there are like noises in behind. And from this, it uses a method called dynamic time warping methods, where it takes the temporal and spectral variation into account and only compares the structures between different sounds to give us a score called the similarity score. So lower to 0 means it's more similar, closer to 1 is less similar. And this is basically how the pairs were structured among my data set. And so from this, I got like a threshold. So below this score is likely for me to extract the more chance of the shared phrases to be detected. So after we set the threshold, we had 3 experts and 3 non-experts to assess like all the phrase types within this threshold and extract the really same shared phrases. And from this, we had some results of the shared phrases and the number of males who had the shared phrases within these 3 data sets that we had. So as you can see, all the shared phrases within the data and the number of males who shared the phrases were both higher within locality than the big citizen science data set. And this is also by the distance. You can see within like a smaller scale distance, there were more shared phrases than the higher distances. And also we also found that what we call popular phrases, so what this means is not only, there's no rule like only 2 males will have the same phrases. Some phrases are like sung by like 9 males, for example, which is very popular for somewhat reason. So these like the more popular the phrases are, of course, the less phrases there were. And most of the phrases that we found were considered unique, which means so like they do discriminate each other from their phrases and their repertoires in total. And for the very popular phrases were mainly found in within locality than far distances. So to briefly go over this map, this is phrases shared by 2 males, which is even found in like larger distance, 3 males also, but from 4 only in Vigina and Swiečka, only also in Vigina Swiečka, and from 6 it was only found in Vigina, and also there was a phrase even sung by 9 males in one locality. So to answer the questions that we asked in the first place, so by distance, do neighbors really share more than far distance males? Our answer is probably yes. And the reason is because, as I said, they're quite sedentary, and their maximum dispersal rate is like less than 10 kilometers within the Central Europe population. Regarding our, from the info of like a ringing center in Czech Republic. So it makes sense that by the dispersal rate, they will likely learn from the close neighbors, their songbirds, so they learn. So the sharing will be more often within the neighbors. Still, we still have to see the distance within the locality, where really if you're close within the locality and even within the locality you can't hear the birds, do they really sing? So it will also be checked. For the dialects, we are still looking into the data, but so far, at least what we see is it is likely not really correlated, because even this dialect distribution is very patchy and mosaic-like, so it doesn't really have a relationship with the dispersal rate. So this is actually the second chapter that I'll probably work on, how the distribution of dialect is correlated to what. And with the popular phrases, as you can see, even though like some phrases were popular, all the repertoire of the combination were all unique. So we can actually really tell the individuals just by their repertoire. So you can see that the song individuality is present in the species, and this is really helpful for individual identification, which my colleague will give a talk on Wednesday probably in more detail about the individual identification. And 3:15, Ilaria Morandi here. And so what we're doing right now, this was just a brief introduction of my chapter, but right now we are actually collecting still more data about this species. And in our field site, Regina, the first site that I mentioned, we have a data that has been collected since 2019, where we all have the males' territory maps just by their acoustic monitoring. And this year we actually put like 35 audio moths on this very small 2-kilometer transect to have like a full coverage of the locality. So if anyone's interested in this data set and maybe want to discuss or collaborate more, we're always open. And another emphasize that she's giving a talk tomorrow, and we're working on the audio moths all together. So I think it'll be a very interesting talk. And with this data, we're actually part of a bioacoustic AI project, and Ilaria is also part of it. And there's Celine, who's giving a poster just back there. And our project is about using AI methods in bioacoustic research. And in the project, my main topic is like trying to figure out a way of individual identification more further than species identification, which we use a lot in bioacoustics. So yeah, and this is it for the talk, but as I said, we are always open, so if you have any questions or any feedback, I'm happy to discuss. Thank you.
Anyone with a question?
Is the repertoire you were talking about specific to this, or is something that many repertoires like that?
I think the definition of repertoire is actually quite used often in other species. I think I also saw some talks that are regarding this. But at least in my species, it basically means like the combination of the certain phrase types, so which we call like a combination one male can sing for his basically whole time of singing. So that's what we use to identify the species, I would say.
Hello.
Me again. Just I have a question about you talk about the similarity among neighbors, and do you think that it can maybe due to genetic proximity if there are brother and sister or something like that, or?
Yeah, that's definitely something we are also considering. Maybe that we can collaborate with some people with like regarding genetics, but it does make sense since like you said is they have lower dispersal rate, so they maybe like regarding to genetics they share more, but I'm not I think there's a trade-off at least for this species, because rather than genetics they're actually songbirds, so they do learn songs from their neighbors or tutors, we would say, when they like first acquire their ability to sing. Because even on field, when you go, like juveniles sing very weird songs, and at some point they stabilize their own repertoires and start singing a very certain type of phrases. So it may have a relation with genetics, but it may have not. So I think that's something we can definitely check.
Thank you.
Very nice talk. Thank you. One practical question about the high automorphs. What is your experience with their reliability? I've heard something about 20% of them fail during field work.
Sorry, for hours, 20%
Yes.
failure.
What is the reliability of the audiomorphs?
So far, actually, it's our first time trying Audiomoth this season. So we started the field in February, and so far, we haven't really used the data set yet for like further analysis. But for individual identification, I think Ilaria will explain more tomorrow, which is so. But it's very like first step for us, and we did like very preliminary tests last year, and based on that we're trying to apply it this year, and with our collaborators we're still working on the individual identification for the AudioMoth data. So
but my
we're not
question
sure yet.
was
Yes.
more that a colleague of mine in the US experienced that he had bought a large number of AudioMoth, and around 20% of them failed during the field work, so he did not get any data at all from those. So I just wanted to hear if you had gotten some data from all of your AudioMoths.
Actually, I think what I also find surprising, last year we did test and deployment for like a month or so. That time we failed a lot, like you said, like rain or like I don't know, we don't know what reason, but like we would go the next week and it would like completely malfunction. But this year, so far since February, we didn't find major. Exciting. We didn't find. I think we had like 2 or 3 among 35 that was like we had to change during the season. But so far, I think it's quite successful. Not as much.
Right. Thank you very much. And now we are going to welcome the next speaker. So Singh Pajit, who is going to talk about geographic variation in non-songbirds vocalization.
Hello everyone. Today I'd like to talk about study on non-songbird vocalizations. This was an undergrad project that I did, and it's been resting in my personal archives for a while, and I really wanted to pull this off and rebuild on this. So, as we know, in birds, vocal communication plays a very important role in governing important social as well as sexual behaviors. It could be behaviors like contact, but also other important behaviors that govern courtship, like territoriality, group membership, and so on. And broadly, we can categorize vocalizations into calls and songs based on their structure as well as behavioral or functional context. While calls are shorter, simpler, and used in making contacts, begging, or alerting of a predator, something like that. Songs are usually longer, complex, and used in behavioral contexts like courtship. So you can see sonograms of a call and a song here. For the purpose of study, we can decompose a song into syntactical structures like note, syllable, or a phrase. Usually, note is a single continuous trace of a sound, while syllables are a combination of notes that occur in a particular order, discerned by certain time gap. And when syllables occur in particular order, they constitute a phrase which, over extended period of time, compose a song. So how are these vocalizations acquired? Our understanding is that they acquired either through vocal learning, that is they are learned, as we know in case of most songbirds or Oscine birds, and they are also innate or genetic in many other birds. So vocal learning is explained by the auditory template hypothesis, which posits that individual during the sensory motor period learns its song by matching it to that of its tutor in a conspecific population. While the innate vocalizations are thought to be they do not rely on vocal learning, but they are acquired by the individuals. And there have been captive rearing experiments which have showed that even when you isolate a juvenile in its early days from its population, they're still able to reproduce the same vocalizations. Vocal learning is not limited to Oscine songbirds, but has also independently evolved in parrots, hummingbirds, and sub-Oscines like three-wattle bellbird. However, all other non-Oscines are thought to acquire their innate vocalizations through genetic basis with diminished or little role of vocal learning. So coming back to the species with vocal learning, and here we take an example of parrots. We observe that because of introduction of errors in learning or selection for certain song types in localities, there are regional or local variations of songs. And they are geographically unique, and from one locality to other locality, they differ very sharply, similar to human dialects. So besides hummingbirds and parrots, what do we know about song learning or vocal learning in non-songbirds? Turns out not much. Most taxa have never been investigated or studied systematically, so much so that Oscine songbirds have become our default reference model for studying vocal learning and associated themes. In this phylogeny by Carroll Kent Tate, they summarize and highlight a few taxa where they observed anecdotal evidences of vocal learning or modification in non-songbirds. And this calls for a systematic and careful study across taxa for presence of any vocal modification or instances of learning. So in this study, I looked at 5 of the non-passerine species, namely fulvous whistling duck, common cuckoo, common loon, Eurasian hoopoe, and black kite. The vocalizations were obtained from publicly accessible bioacoustic repositories like Xenocanto and Macaulay Library. Then I filtered those recordings to remove highly variable and poor quality recordings, and I subsetted those recordings for particular vocalization types for each of the species, and I tried to focus on vocalizations that are relatively complex and longer, and avoid calls which are contact calls, begging calls, or flight calls which are very variable. Then these were processed through the Raven Pro to generate sonograms for qualitative comparisons across the sonograms, and also imported into the R statistical environment for basic quantitative analysis to test for hypothesis regarding innate vocal of these songs. So what do we expect to see? The 3 broad macrogeographic patterns of vocalizations that we would expect. The first being one which is random across distance. The second being if the vocalizations are purely innate, then we would expect to see a clinal or linear variation across distance, consistent with process like isolation by distance. And the third one being if there is a significant amount of vocal learning happening, then we would see a pattern which is similar to Aussian songbirds. That is, you would see a stepwise variation in the song parameters, exhibiting some sort of dialects. So I'll quickly run you through the results we have. And we did linear regression and mantle test. And for simplicity, I'm just highlighting the results which are significant with a box around it, the bold box around it. So white crown sparrow, we took this as a positive control species because this is a songbird very well known for song learning. And here we looked qualitatively at the sonograms. Then you can clearly see there are two different dialects as you see in Utah and Alberta. And quantitatively, for phrase length, we saw that there is low to moderate correlation across distance. The other parameters did not exhibit any other correlations. Then we looked at fulvous whistling duck, where we chose one of the vocalizations with 2 syllables. And again, for fulvous whistling duck as well, there were no statistically significant relationship among any of the variables with increasing geographic distance. However, the number of harmonics and overtones did vary across localities. Unfortunately, I could not test for that or compare that because the recordings I obtained, they were done from varied kind of recording devices, and a lot of recordings were clipped, so I could not capture the entire range of overtones in my samples. For common cuckoo, again, they were for intersyllable gap, phrase length, and phrase peak frequency of the phrase. We saw some low linear correlation, but otherwise there wasn't any much variation. Coming to loon, we saw that qualitatively I saw a couple of recordings where the number of syllables in the second phrase were extensively high. So usually you'd see 3 to 4 syllables in the yodels of these common loon, but I saw some of the recordings where those were very high, like 8 of these syllables here. When I looked at black kite, this was a case where there's a lot of variation within vocalizations of individual, even within a particular locality. So let alone across large geographical distance, even in same locality, there was extensive variation in black kite vocalizations. For Hupu, again, there was statistically could not find any significant correlation. However, qualitatively, I saw that some of the recordings, they had alteration of, they had unique phrase types where the phrases with 2 syllables and 3 syllables were alternated, and a recording from Ukraine showed spectral blips in between the different syllables. Overall, cuckoo vocalizations seem to align most closely with the notion of innate and inlet vocalization that supported the hypothesis with clinal variation. However, there was no uniform trend across localities. Black kite vocalization was heavily, it varied a lot even within localities. Common loon, again, for common loon, fulvous whistling duck, and Eurasian hoopoe, we accept the null hypothesis because there were no significant correlations. However, qualitatively, we did observe that there were some variations. So of the 5 species I studied, only one of the species, common cuckoo, showed support for clinal variation, that too in particular song parameters. It could indicate that certain aspects of certain vocal parameters seem to exhibit different variation across species and orders. I'm very mindful that my sample sizes were low and they were very much limited by whatever recordings I had back then when I was doing the study. So we need more fine grains happening to actually test for whether we have a dialectal or random variation here. And yeah, a future analysis could use spatial autocorrelation to clarify the role of distance in the analysis. I'd like to thank these institutions and individuals for supporting my work, and I'm open to questions and feedback.
Hi, really good talk. Thank you, so interesting. I wanted to ask if you'd observed any geographical variation in alarm calls of any of these species? Or is that not what the data was really about?
Actually, at the very get-go, I avoided looking at calls and was trying to look at vocalizations which seem a little more complex. So yeah, I did avoid begging calls, flight calls, and alarm calls. In the initial sampling, I also observed there were not many recordings for alarm calls across distances for it to be like a big enough data set for me to look at across different orders. So I couldn't do that.
And do you have any adjoining behavioral data with?
Unfortunately not. These recordings that were already on Mekele Library or on Zenocanto, whatever the annotations and remarks were left there, I just inferred behavioral context from there. And after a while, I think I picked up that what kind of songs are associated to what kind of context, but not much of behavioral data that I had. And again, this did not involve me like primarily going into the field and doing this. So I heavily relied on the data that's already there.
Okay, cool, thank you.
Yeah, thank you very much also for the presentation. I was wondering, so from what I understood, your data set is like it has been picked directly in Xenocantos and those libraries, is it?
Right.
Like, how do you consider any effect of the environment on the recording itself? Not like, I mean, it has an impact on the quality, of course, but also sometimes, like, is there any possibilities that the location itself may shift, I don't know, like some frequency detection or thing like that?
Yeah, I'm not sure if we could control for the effect of environment on the recording itself. But if you're asking about the effect of the locality or the place or like microhabitats on the vocalizations, then that could be like, there could be that in microhabitats or in certain habitats, certain songs or calls are selected for in certain ways. But yeah, I'm not sure if I had a way to actually like look at and evaluate whether the environment itself was affecting the recording in certain ways. In general, I tried to avoid recordings which had a lot of noise. So I did classify the recordings into certain quality classes and ignore the rest, if that helps.
We have time for maybe one short question. Okay. All right. Thank you very much, everyone.
Thank you.
And I think it's time for lunch, so let's go.